Let's talk about array as a design choice for implementing LRU cache. So first, if we look at what operation are we exactly looking for in LRU cache, so there are three operations. Imagine like we implement this as an array. Now you'll wonder, like, there are two things to store. There is a key, there is a value. How do we store that in a array? So ideally, if you have to implement it for a key and value, you can imagine taking two arrays. One array will store the keys, and at the same indexes other array will store the values. So this is one naive way of implementing. You take two arrays, like if you are storing key at 0th index here in first array, store the value at 0th index in the second array. But for the sake of simplicity right now, just assume that key and value are same. So treating like there is only one array we are going to use. So let's move ahead. So imagine this is the array that we have taken. So this is 5 element array. So we are assuming n is 5. So creation of an array is not a big deal. We can directly declare the array with size 5. So that is taken care of already. Now if some numbers come, let's say 2 is the first number that we are going to use. Ideally in array we can store from the beginning to end, or we can store from end to beginning. Any choice is perfectly fine. I'll take one example and I'll take it from the back. So assumption here is anything that we want to evict, we will store at the back of the array. That means if an element is stored here, let's say if 5 is stored here, this is the element that we need to evict. As simple as that, right? So element store in the end is the least recently used element. So during insertions we will try to maintain that property that last element always is an element that was used way back. It is not a fresh element. You can say the fresh element will keep getting stored in the in this order. So here it will be the most fresh element, here it will be second fresh element, here it will be third fresh, fourth fresh, like that. So in case you have to delete something, this is the place of deletion. So we are sticking to that we will be filling elements from the back side. That's our strategy. So let's begin from here. Now first this 2 has come, so what we do is let's store 2 here, and so far the freshest element is this, because this is the beginning index as of now. Then 5 comes. So when 5 comes, 5 is more fresh than 2, so we know 5 will be stored before 2. So this is what we will do with 5. Now third thing is 2 comes once again. So when 2 comes here, what is it that we should do? Ideally we are saying that 2 is now more fresh than 5. So in worst case what we should do is, if 2 is more fresh, let's copy 2 into a temporary location and we shift everything which is filled in the array to its right. So 2 will be taken out, stored in temp variable, 5 is shifted to the right, so 5 comes here, and 2 we store in the first empty location that we get in this array, right? So that way we will say because 2 is more fresh, we are maintaining the order and putting 2 in the front. So this is what eventually this array will become when 2 comes again. So we have processed first 3 elements, and now the state of our LRU cache, which is stored inside an array, is this. So we have 2 and 5, and looking at this array, it tells 2 is the fresh and 5 is little stale as compared to 2. Now next element that we are processing is 1. So when 1 comes, we know 1 is the latest entry, so 1 is the most fresher, so 1 will be stored here. So this is what the order for now is. Then comes 9, so we know 9 is the most fresh element, so 9 we store in the beginning. Then comes 1. So when 1 comes, we again see, like we search where is 1, 1 is here, so 1 is the freshest element, so 1 should move forward, so 1 should ideally come forward. So what we do is we copy 1 in a temp variable. Now this slot gets free, everything to the left of 1 moves to the right, so 9 comes here, and the first free slot is this. So what we do is 1 and 9 get swapped kind of, so 1 moves here and 9 shifts here, right? So this is what our new strategy is till this 1. Now when 0 comes, what we will do is 0 is the freshest and the first empty slot is this, so we store 0 over here. Now this array is giving us the order of fresh elements, right? So if 10 comes, we are very clear that when 10 comes, the element that we need to remove is 5. So what we do is we remove 5, we store it in a temp variable, we move everything towards the left. Since our data structure has reached its full capacity, if we want to store a new item, we'll remove the last item, shift everything towards the right, and the new or fresh item we store in the beginning. So our array will actually become, it will become 10, 0, 1, 9, 2, and 5 will be removed. So this is our implementation of LRU cache using array.